All right, ladies and gentlemen, welcome to lesson 1.2, function notation. I forgot to mention the last couple lessons that if any time you want to pause my video, give any of these questions a try before I go over them, you are more than welcome to do that, okay? So, for example, if you want to try the warm-ups on your own, you can pause me now and then do them and then unpause me and you can check with the answers, okay? So if you'd like to do that, please give that a try and gather some independent learning. That'd be great. All right, so here's some warm-ups, ladies and gentlemen, before we get into our lesson. Which of the following are function, state, why or why not? So looking at the first one, this is a mapping diagram where you've got your input, which is an x, and your output, which is really a y. All right, so looking at this, ladies and gentlemen, does each x have its own y? And you're going to say, hey, looking when x equals 0, there's two y's. So this answer is no, it is not a function because x does not have only one y when x equals 0. Because it goes to y having -2 and 1. Okay? Just going to fix my have up, ladies and gentlemen, because it looks funny. And that's the problem with live video. I can't really stop my corrections. You may find from time to time I might make an error as I'm doing a solution and we have to back up and erase, and I apologize. That's how video feeds work, okay? I can't just change this part of the video. So I hope to have more correct answers than non-correct answers, but please have some patience if I do make a mistake. It's going to happen, okay? All right, taking a look at example B. Okay, we've got our x and our y, and is this a function, ladies and gentlemen? Yes, it is, because each x has its own y value. All right, good. All right, let's take a look, ladies and gentlemen, at our graphs. And again, if you need or want to take a ruler out, straight edge, I'll change my color this time. There we go. Okay, so if I grab any straight edge or ruler and I go vertically left to right, again, here's an example of a parabola. So is this a function? And the answer is yes, because it passes the VLT. Okay, taking a look at this, this is a winter temperature over 14 days. Okay, so as I go from left to right, I notice that, hey, we are good. Nowhere does it double. Don't get confused right here where the horizontal line stays the same. It's still only one spot on my vertical line tester. Okay, so yes, because it passes VLT. Good, hopefully that was a good warm-up. Now we're going to get today into function notation. All right, so in algebra, ladies and gentlemen, we use variables like x and y to represent numbers. Okay, with functions, since we have each x value leads to only one y value, we don't write y anymore. Instead, we write f at x, g at x, h at x, h at t, c at n. There's a whole bunch we use, ladies and gentlemen, to represent the dependent variable. Okay, so how do we read this? F of x or f at x? You can do either or. Okay, so ladies and gentlemen, if we take this example, y equals x squared plus 2x plus 4. Since this is a function, because it's a parabola when we graph it, we write it as f at x. Okay, and what we do, ladies and gentlemen, is we can sub in values. So I could say, hey, what is f at 2? What is f at 3? What is f at 4? And we're going to get to that in this next line. Evaluate f at 3 means find the y value when x equals 3. Okay, so f at 3, in this case, ladies and gentlemen, equals, wherever you see an x, we're putting a 3. So 3 squared plus 2 times 3 plus 4. So use your mathematics, ladies and gentlemen, BEDMAS, okay? You don't need to show me all these steps, but if you need help, 9 plus 6 plus 4. You could plug that right in your calculator at this level, grade 11, and go right to the answer. So I don't need that mid-step unless you want it. And you should end up with 19. What does that mean? The y value on your graph when x equals 3 is what it's going to be. All right? Good. Okay. Remember that y and f at x are essentially the same. So when you have f at x, g at x, h at x, they really only represent the same thing, y. It's just specifying, all we're doing, ladies and gentlemen, is specifying that no longer is this just a relation. We've also told you it's a function. It's a function notation, which means if you graph it, ladies and gentlemen, it would pass the vertical line test. You would never see f at x equaling that circle formula because guess what? It is not a function, so you wouldn't see it. All right? Good. So, ladies and gentlemen, let's evaluate some of these. Now, be careful. When you do your homework today, watch the lettering very carefully. This is f at x, g at x, and h at x. We're asking for different things here. Okay? So, f at x means you've got to look at the, f at 2 means you've got to look at that one. Okay? So, looking at that, ladies and gentlemen, what does that tell us? It tells us that wherever we see an x, we're going to put a 2. So, it's going to be 2 times 2 cubed plus 3 times 2 minus 5. Okay, use BEDMAS, ladies and gentlemen. 2 to the power of 3 is 8 times 2 is 16 plus 6 minus 5. Again, you can plug it all in your calculators. I'm not testing you if you can do BEDMAS or not. I hope that at a grade 11 level you know that. Okay, what does that mean, ladies and gentlemen, just in case? Therefore, ordered pair 2 and 17 is on the graph of f at x. Because remember, g at x and h at x are a different graph altogether. So let's take a look at an example. Here, b, g at negative 4. So what does that mean? G at negative 4 equals, wherever I see an x, I'm putting a negative 4. So this is a linear relation, ladies and gentlemen. Okay, so what you would have is negative 8 plus 1, which equals negative 7. What does that mean? That therefore, on your line, you're going to have a point negative 4, negative 7 is on the graph of g at x. All right, now we're going to do some harder ones. Get ready. H. Okay, h at 1/2. Okay. All right, so h at 1/2 equals 1 over, here's my substitution, 1/2. Okay. Now, ladies and gentlemen, you may have been confused about this, but when you have a fraction divided by a fraction, so 1 is really 1 over 1, right? Divided by 1 over 2. Remember, you do the invert and multiply. Okay, so let's do that. So what's that going to equal? That's going to equal 1 over 1 times, flip that second fraction, so it's going to become 2 over 1. When we multiply, 1 times 2 is 2, over 1 times 1, which is 2 over 1, which is just 2. So therefore, ordered pair 1/2 and 2 lies on graph of h at x. You might be saying, hey, Mizar, that h at x, that's a pretty funny looking equation. We're going to get to that. That's called a reciprocal function, and we'll be getting to that later on in this unit. Or the next unit, can't remember, but we're going to get to it. Don't worry. Okay, last question, and this is a tricky one. So we're back to our f at x equation, but in this case, wherever we see an x, we're going to put a 3b. So what does this equal? 2 times 3b, and that's all cubed, plus 3 times 3b minus 5. Double check, ladies and gentlemen, that you weren't missing any exponents. So let's double check that we've subbed that in correctly. So this looks right. Yep. Got the exponents up there. And this is where students, I run into trouble. The 2 is fine, but when you multiply through here, just remember that this cubed affects both the b and the 3. So 3 times 3 times 3 is 27, and b times b times b is b cubed. That's where I run into trouble. People would write that down as either 9b cubed or 3b cubed and forget that that exponent affects the coefficient as well as the variable. All right, glad we've cleared that up. Plus 9b minus 5. And lastly, ladies and gentlemen, we got 54b cubed plus 9b minus 5. And we can't collect any like terms, so we are done with that question. All right. Now, another way to discuss about function notation is when you're given a graph, because you can discuss a function with an equation like this example, or with a graph, or even a word problem. Okay? So taking a look here, this is a little bit backwards thinking. Okay? So f at -3, so our function is on the graph, which is this dark line here. I'll color it in blue just so you can see it. Okay, so this is our function we're talking about. So this is basically f at x. Okay? So what does this ask us? It says, hey, find f at -3. So what does that mean? We got to find y when x equals -3. So what do? When x equals -3, we are here. And where does it hit the graph? Right there. So it's the value of y, okay, or f at x. So this is x and f at x if you want. Okay, so what's the value of that? F at -3 equals, where does it hit? 3. Okay, next one, I'll change colors. F at 0, that means, hey, what's my value of my function when x equals 0? So when x equals 0, I'm here, go to my graph. Okay, so that tells me that f at 0 equals 3 as well. Okay, f at 2. Okay, change colors. What does that mean? Hey, that means x equals 2. What does y equal, or the function equal? So at 2, I actually go down. So f at 2 equals -2. All right. Now this one is crazy backwards, okay? So what does this tell us? This tells us really that y equals 6. What does x equal? We've got to go backwards, so I'll use black for this one. Okay? So if I go to 6, y or f at x being 6, where does it hit? It hits right here. So what does that tell us? That x equals 8. Now how do we show that in proper function notation? Therefore, you tell me f at 8 equals 6, and you substitute the value in. All right? Well, there is our first lesson on function notation, and we'll be using functions for this whole course because guess what? Our course title is called Functions. We'll be doing this a lot. All right, here's your homework, guys. I don't know why I've got 2 pages in there, but homework page 22, numbers 1, 2, 5, 6b, 10a, bd, 16 and 17. Notice, ladies and gentlemen, when I star them, those are usually your more challenging questions. Those are usually like your inquiry type questions or high-end thinking application questions. Please always give them a try. Another comment I shall make, ladies and gentlemen, I'm quite aware that you guys will be working or have extracurriculars, hockey, gymnastics, swimming, whatever. I want to make sure that you realize I don't check homework. It's up to your responsibility. You're going to get out of this course what you put into it. So if you know you're stressed for time one night and you don't have time to do all your homework questions, don't just do the first 3. Pick one from the middle, one from the start, one from the middle, one from the end. Okay, if you're limited to only 3 times, you can do it. And then by all means, you can always come back and do your homework questions later. All right? But please, do the best you can to be successful. And I'm here to help you along this journey. All right? Have a great day, folks, and get as many homework questions done as you can. Goodbye.